It's not really simple to go from knocking out a gene in an animal to capturing Alzheimer's in a petri dish, but it's being done.
The power of our democracy.
What about pushback from some who say that in vitro models for some diseases, come a long way, but the majority of animals used in biomedical research are a necessary part of preclinical toxicity or carcinogenicity studies, since humans are eventually going to be receiving these treatments eventually? Wouldn't leaving out those intermediary steps of animals end up endangering or killing human subjects?
This is, it's an interesting argument. The thing is that there's a 95% failure rate. It's already happening. It's not like we're keeping everybody really safe by testing on animals. And the argument is that a lot of people are waiting for this magical technology that's going to replace it all. That's applicable to each scenario, but that's not how it is done. And my answer to many of these researchers who are willing to consider anything beyond animal testing is that what we have at our disposal is a versatile toolbox that has a large number of tools that you can configure anywhere you like, depending on the question that you're trying to answer. So it's not a matter of just, if you can't do it all, that you're not going to do anything at all. But what we have is a toolkit, perhaps none perfect as standalone, none that fits all. But if you use the whole toolkit, instead of just the hammer, you could study human biology in a different perspective. And that's the only way to really reconcile this. It's not really simple to go from knocking out a gene in an animal to capturing Alzheimer's in a petri dish, but it's being done. And when you think about especially the progress that we made in toxicology, so one of the big examples, and this is a procedure that's now approved at the Organization for Economic Cooperation and Development. So the OECD has a chemical test guidelines program. And the 35 OECD nations, including Canada, participate in this test guidelines program. And last year, they approved this one procedure that completely replaces mouse and guinea pig testing. So for something called skin sensitization. This is where you get a skin rash or an adverse reaction, an allergic reaction in response to repeated contact, skin contact of a chemical. This is normally, and this has been for the last few decades, being done with mice and guinea pigs. Those tests were completely replaced by essentially 2 human cell-based tests. This is how simple it can be sometimes, and it required a completely different mindset. It required a completely different way of thinking to address that issue. How do you figure out if that chemical is going to cause an allergic reaction? And people did it by working together. Different disciplines came together, and now it's a simple, what's known as a defined approach, simple approach where you take a chemical, you put it through your first test battery. Actually, the very first step in that procedure is in silico. It's a computational model, and you have your chemical, you put it through the first test. If it's positive, you do a second one. If it's negative, you can essentially be confident that it's not going to cause an allergic reaction. This is how sophisticated it can be, even with a simple cell-based assay. You just have to be open-minded and be very creative to develop what we need to capture that human biological complexity. It's doable. There's no excuse for it.
Are there some things in medical research for which we just simply can't get away from animal models? Like in the development of the COVID-19 vaccine, were animals used, and were they necessary, or we couldn't have made it as quickly? Or are there alternatives in that form, in that type of research as well?
So if you're talking about replacing all animal tests like tomorrow, no, we're not going to be able to replace all animal testing. There are some, biological phenomena that we haven't quite been able to reproduce yet. But that's not to say that in 10 years' time or 20 years' time that we won't be able to. And yes, while we have some of those things that we are still trying to develop, we also have a lot of other things that even if it's not one single method, as I said, that could replace what you want. Maybe there are 5 different methods that in combination will give you enough information about the biology underlying what you're looking at. So yes, we are not ready to end animal testing tomorrow morning in certain areas. And one of a specific example that I can think of is some of these in vitro methods, right? These tissue models, for example, are lacking blood vessels and nerve innervation. So the nervous system controls a lot of physiological responses. So how do you incorporate that? And so the next generation of these models, that's exactly what they're doing. Even in our 3D models in my laboratory, we're incorporating blood cells, and trying to create that interaction. And then organ interactions. They're with these chips, they're combining multiple chips together now to create human on a chip. So you will have your kidney, liver, GI, heart, brain all together connected.
So with in vitro, will you be able to somehow replicate and manipulate the metabolic and hormonal activity and cell structure that can basically reliably recapitulate what is seen in humans? Do you think we're close? We're there?
That's happening already, and people are incorporating immune cells into these systems. Some of these companies that have sophisticated organ chip models, they've already incorporated immune cells, so you can see immune cell recruitment into these tissues, depending on chemical exposure or disease condition. Blood vessels being incorporated, nerve innervation, hormonal signals. Yes, it's all happening. There's a lot of progress that's being made. I mean, the next 10 years, I think it's really exciting to see what's unfolding right now.